And there are various testing frameworks in Haskell, test harnesses that can organize your tests, label your tests, group them, and so on. But Plutus uses the so-called Tasty test framework. You can find Tasty on Hackage, and there's also an example. So basically, you have a main program that uses, for example, default main and then some tests, and tests are of type test tree. And as the name suggests, a test tree is a tree of tests, so you can group tests and have subgroups and sub-subgroups and so on. There's special support for tests in Plutus, and that is provided in module plutus.contract.test in the Plutus-contract package. And there are various types of tests that are supported, but today we'll only look at two of those. One that works with emulator traces, and one that's much more sophisticated and uses so-called property-based testing, which we will look at next. But let's start with the emulator trace-based tests. So in this module, there's the chapter on checking predicates, and there we see the connection with Tasty. So there's this check predicate function. It takes a descriptive name of the test, then a trace predicate. We'll get to that in a minute. And then an emulator trace, like the one we just used to manually test our contract. And the result is a test tree, which we just saw is the type of tests that Tasty uses. So by using this check predicate, we can produce something that the Tasty framework can understand. There's also a variation, check predicate options, where we can set some options. So there's one additional argument of type check options. And if we look at that, then we don't see any constructors, so they are hidden. And in order to access the options and set various options, you need these operations here. And they have this weird type that we haven't seen yet, this lens prime. And that is related to something called optics in Haskell. And that is a huge topic by itself. And whole books have been written about optics in Haskell. So I will ignore this for now, just show you how to use this emulator trace, and then say a couple of words about optics. Unfortunately, I can't go into detail there. And I find it a bit unfortunate that you are basically forced to use these optics in order to work with this library. It would, in my opinion, have been better to expose the constructor so that we could have, without using optics, interacted with this check options type, for example. But in any case, so this we can use here, this emulator config lens, to actually set an emulator config like we did before when we ran the manual trace to specify an initial distribution of funds. There is one way to modify check options without using lenses, namely using this function here, change an initial wallet value. So given a wallet and a function that updates the initial value and check options, it modifies those check options into check options where the given wallet has this function applied to its initial value. And I actually could have used that, but I didn't. And you also have a little bit less control using this because you have no influence on the initial value. And in my trace, I wanted to go with 1000 ADA. And you also here can't really change what wallets you have. So you would end up, if you start with the default check options, with these 10 simulated wallets. And in my trace, I only wanted the 3. But in principle, I could have used that as well. Going back to the check predicate function and its cousins, the one ingredient we haven't looked at yet is trace predicate. And the trace predicate is a predicate on a trace, as the name suggests. So a condition on a trace. So that's the actual test. So given a trace, it is a condition that will be checked by the test. And if we look at the definition, it looks complicated, but we don't really have to understand that. So let's just check. So first of all, we see that there are logical combinators. So given a trace predicate, we can negate it. Given two trace predicates, we can perform the logical conjunction and the logical disjunction or. And now there's a wide variety of available predicates. That's here in this assertions chapter. So there are all sorts of things you can check that a given contract has run to completion or has not run to completion, that an endpoint is available, that an error happened. And if you scroll down, there are all sorts of interesting things. But we, as an example, will only use one, namely wallet funds change. So that will check that for a given wallet, after the trace is completed, the wallet funds will have changed by this given value. And if you look at the comment, then in particular it says here excluding fees. So often, as we saw in the examples, the value change is not really predictable because there are always these fees and the fee calculation is quite complicated. So this is nice. This predicate allows us to ignore the fees and just look at the value change without fees. However, if you insist, there's also a variation of this valid funds exact change where the fee is not automatically taken care of. Going back to the module, we can now look at this tests function here. And I'm using the check predicate options variation because I need to specify the options because I need to communicate that I want to use this emulator config where I specify the initial distribution of funds. And the way I define these options is I start with the default check options and then set the emulator config part to this EM config that I had defined before and that we already saw in action when we did the manual trace. And this weird operator here is part of optics. So it basically says to set the emulator config part of the check options to this value. But as I said, we'll look at optics briefly later. Okay, so I have my options. The next argument was a name. So I just say token sale trace. The last is just a trace. That's the same trace we looked at before. Now the interesting part is the predicate. And if this is defined here, and I'm using this logical AND to combine three predicates, and I just use this wallet funds change. So for the three wallets, I just say what I expect, what happens, and that's the same calculation that I explained before. So for example, the second wallet should lose 20 ADA because it buys 20 tokens for the price of 1 ADA each. And it should gain 20 tokens. Same for wallet 3. And for wallet 1, also same, but I have to take into account this min ADA deposit. So the fees are taken care of automatically when I use this wallet funds change trace predicate, but not the min ADA deposits. So how can I try this out? As I said before, I do have a part of the Cabal file, a test suite, so we can run it using Cabal, and we will do that later, but there are also other tests. So now I can also just do it from the REPL. So I'm again in this test suite in the module spec trace. And if I do import test tasty so that I have access to this default main, then I can do default main tests. And we see it passes. Of course, it would be more interesting to see what happens if it doesn't pass. So let's say I expect something else. For example, here instead of 20 tokens, I expect 19 tokens. Then we get much more output. So in particular, here we see the whole trace. If we scroll up to the beginning, we see quite a nice error message. Expected funds of wallet 2 to change by minus 20 ADA and 19 tokens, excluding 10,631 Loveless in fees, but they changed by 2020. Discrepancy of 1 token. So I think this is really nice.
so it easily points you to the error.
This is probably the simplest and easiest way to write automatic tests for Plutus contracts. You simply write one or more emulator traces and then use check predicate in combination with appropriate test predicates to check that those emulator traces lead to the desired result. And what you get is more or less traditional unit tests.